Okay.
Yeah.
Okay. So last week we were solving some problem, right?
Yes, uncle. Vectors and the circle one theorem you had asked.
Ah,
That we.
okay. So 1 second, let me take the whiteboard. Okay, let me share the whiteboard here so that we can start working on it. Can you see the whiteboard?
Yes, uncle.
Okay, good. Okay. So now tell me which one, something in the circle, what?
Yes, uncle.
What?
So in a circle,
Yeah.
1 second. I have the PDF, 1 second. Yeah. So in a circle, the tangent is 90.
Ah, yeah, okay. Did you work on that?
Yes, uncle. I think I know how to do it.
Okay, so let us draw a circle and then let's think that there is a tangent which is right.
Yes, uncle.
So if you extend this, we are saying that this one, and if you draw a radius, okay, that radius, we don't need that. It is actually not exactly following that. It is bit like going at this, right? Do you get that?
Yes, uncle.
Yeah, okay, let it be. So this is the 90-degree we have to prove, isn't it?
Yes. Yes.
Okay, so what you did?
Uh, Actually, I think I did it like I thought we could have done it like we can draw a diameter which is parallel to the tangent.
Okay, draw the missing, this one.
No. Parallel to the tangent itself.
Parallel to the okay, you want to draw one parallel to the tangent will be like this, right?
Yeah.
Okay.
So I thought we could use alternate angles and prove it.
So did you prove it or not?
Yes, uncle.
Then tell me what to be done next. This is
Yes, uncle. So we know that the alternate angles should be equal.
No, I'm not good at all these alternate angles and everything. Like terminology is too much for me. Tell me, okay, let us start naming them. Okay, this is our point of interest. Let's start with this is the tangent touching point T, right?
Yes.
Let's call this is a B, and this is a C, for example, if you want. Okay. Now tell me which angle you are talking about.
Okay, so angle.
This is our point of interest, isn't it? The tangent
Yes.
other end is called that I or something. Okay.
Okay. So angle ITO.
ITO is our 90 degree, isn't it? That is what we need to prove. Okay, ITO
is equal to AOT.
angle AOT.
And also angle ITO and angle BOT.
Angle ITO equals angle.
Not equals. They should add up to 180.
Okay. So add this angle. Okay, so that means the diameter, this one you are saying.
No, uncle, angle BOT. This side. These two should add up to 180.
ITO Why they should add up to 180?
Because co-interior angles, they should be supplementary for two parallel.
Now you are pushing a lot of things because they themselves may need some proof, right?
Okay, fine.
Do you see that already the tangent to a circle, if you draw a radius, it is a 90 degree. That is also given to us. Do you get that?
Okay. Yes, uncle.
So you have to think about proving something from a very basic point of view, like what is already proven to you, known to you. You cannot take, okay, so somebody said so, my teacher said so, textbook said so, won't work.
Okay.
Okay.
Okay. Yes.
Okay, I will leave it to you. Let's try next week. Okay.
Okay, uncle.
Okay. So what else we left?
Uncle, can you tell what did what is the other method as well?
I can tell you, but I don't know whether it is a good idea to help you like that rather than making you to think over and do, because you added a diameter, right?
Yeah.
Which is parallel to the tangent. Like that, why don't you start adding something which can be already known and proven to you? Do you get that?
Okay, fine. Okay, yeah.
Just, I mean, I'm not saying this is the way to go and solve it
Okay.
or something like that. Simply, I'm saying rather than going for all these 180 degree, which itself I asked a question. Rather, okay, this is not the one as a solution I'm saying. Let's say I draw a line here.
Okay.
And I draw another line here.
Okay.
Now, if you tell me this is 90 degree, I won't ask you a question because last week we have proved this, right?
Yes.
This is what I'm saying. So, like this, think like, so if this is 90 degree, then what we have proven. So this angle must be, because this isosceles triangle,
Isosceles, yes.
this is
That should be
equal to
equal to
this, and
yeah.
this angle should be equal to this. This
Yes,
proven is known because of the isosceles.
yes.
Now, call this as a angle which is okay. So we are saying that angle, call this as a T1.
Yeah.
No, I call that as a T2, and T3, for example.
Okay, yes.
Why I split like that? Because I want to call this angle as my T1.
Okay.
And finally, this angle will be my T4. So I split the angle T. For example, the one, so T1 plus T2 plus T3 plus T4 is our 180. Is it okay?
Yes, sir. Oh, so we can tell angle OAT is equal to T1.
No, one second. Now, we know that T2, yeah, T2 plus T3 is going to be 90 degree, right?
Yes,
okay, so directly, so T2 plus T3 is going to be 90 degree. Also, we know that because of that, T1 plus T4 is also 90 degree.
Okay, yes, sir.
Okay, this thing has come out. I mean, I'm just populating whatever but we need to show that
they're equal as well.
What is the angle we are interested? The angle we are interested is a
T3 plus T4 or T1 plus T4.
T3 plus T4 or T1 plus T2. How to prove that?
Okay. 1 second. T2 plus T3 is 90. Okay, and
yeah, okay, almost.
I will say angle OAT is equal to T1.
OAT. Okay. Good idea.
Yeah.
Because this is a single straight line and these two
Yes.
lines are parallel. You are saying.
Yes.
Okay. So this would be a T1. This says these two are equal. Then
Yes.
T1 equal to T2. And similarly,
Similarly, we can get T3 is equal to T4.
yeah, so this is going to be T4.
Yes, uncle.
And these two are equal. Good. You see, this is how this is already we proved, right?
Yes, uncle.
So in this case, we are saying that our so if you take this particular one, if you substitute this guy in here,
Yes.
then that will come to T1 plus T3 must be equal to 90.
Yes.
And also this guy over here, that will give us also another thing as
T1 plus
it's also
T1.
the same T1, yeah, or the other one also. It's okay. This is one way to do that. As we solved it, I have done long time ago, like let's say there is a tangent.
Okay.
Okay. And as you said, draw a diagonal parallel to this.
Yes.
And draw another tangent parallel to these other
Okay.
already. Okay. And make a square. So this is another tangent. This is another tangent. You see what I'm doing?
Yes.
Draw a parallel diameter here. So
Okay.
these angles are going to be 90 degrees because that is a square.
Yes.
And this is a D. All these distances are D.
Yeah. Okay.
Okay. Now this is not that difficult to prove that this is 90 degree, right?
Yeah.
Because this has to be a D. How come it can be a D? Any line drawn touching the two parallel, all of them are D, right?
Yes, sir.
Because they are square. So definitely that has to meet with 90 degree, then only they can be. Otherwise, it become a rhombus or something. Only a square can fit into it. Then all these angles are all 90 degree angles. Then only they will keep a distance, equidistance from. This is a much simpler proof.
Okay.
But
Yeah.
this is also a proof.
Okay.
And there is a one through the calculus also we can prove it.
Okay.
That, no need to. Yeah, let's leave it for another time. Okay. So you see the way of thinking has to be because we are feeling comfy with okay, I have been told this, I know this or something like this. It's not about what I know, it's about what is already proven and gone to a level of very basic thing that can be proven. Do you get that?
Yes, sir.
Okay, keep that in mind. So don't get forced to buy all the theorems and all those things, because every theorem is under question mark. Do you get that for us? Okay. Okay, anything left over from the last?
No, that's it.
It's all okay. Okay. Okay, so then we need to look into new problem, right?
Yeah.
Okay, let me quickly check whether how you are thinking about a problem, something like this. Let me take a problem. Okay, completely out of the blue, not completely out of the blue. So just before the exam, you asked this. So let me go with that. Okay. So you have been given as formula summation. I write it in the summation form. You should be okay with that, right? N equal to 1 to capital N or something like that. Or yeah, write it this way. I is actually running from 1 to N. Okay. What is the answer for this? So if I write it like generic one, like 1 plus 2 plus 3 plus up to N, this is what I have written equivalent. You get that?
Okay. That will be equal to 1 second.
N into n plus 1 by 2.
1 by 2. Yeah.
Okay.
Yes.
So this is going to be our n into n plus 1 over 2. How to prove this? Not by induction. You know induction, right?
No.
You've not studied induction so far?
No.
Induction, mathematical induction is a very big topic. Okay, mathematical induction.
Oh, it was deleted for us this year, so we didn't have it.
Very strange. Okay. What this is, you see this 1 plus 2 plus 3, right?
Yes, uncle.
Plus 2 plus 3 plus dot plus n equal to n into n plus 1 divided by 2.
Yes,
So
uncle.
what is induction is, let's say we add a one extra term
Okay.
on the, so if you add with this 1 plus 2 plus 3 plus go up to n plus 1.
Okay.
Okay, so this is going to be, we know that this is already is our n into n plus 1 over 2 and plus n plus 1. That is the extra one we are adding. So we are added extra piece on the both the side.
Yes.
But on its own, we know that 1 plus 2 plus 3 plus all the way to n plus 1 is the last term. All we need to do is, in the where the n appear, we will
We have to put n plus 1.
This is what is called mathematical induction.
N plus 2.
If you could prove this, this is going to simplify it as a n plus 1 multiplied by n plus 2 over 2. So this also we need to show that that is going to converge like that. So take the common denominator, that will be n into n plus 1 into plus twice n plus 1. So this will lead to our 2 common. This n plus 1 is a common term in both.
Yes, so n plus 1
that, then n plus 2. So these two are equal.
Yes.
This is what is called mathematical induction.
Okay.
Okay, so this is one way to prove that. But there is plenty of ways to prove that. The one, there is a very famous mathematician, Gauss.
Okay.
Okay, so he is a very clever guy. He has done a lot of work. Excuse me?
He's a physicist as well, right? Gauss.
I think that Gauss is a different guy.
Oh.
The Gauss from the physics, I'm not 100% sure.
Okay.
But I think mathematical Gauss is different from the physics Gauss.
Okay.
Physics Gauss comes, there is a Gauss coming from the magnetism, right?
Yes, uncle.
Yeah, that person is different. This guy has done a lot of mathematical work. When you study normal distribution, you study the bell curve, right? The normal distribution curve is also called Gaussian distribution.
Okay.
Gaussian distribution. Okay, so one of the famous one, Gaussian distribution.
Okay.
Distribution. Okay, so that names comes from there. And when you are studied, do you know how to Gauss elimination method? Did you study that?
No.
Okay, so you have not studied that. Let it be. Okay, I mean, this guy, when he was doing his, I don't know, somewhere in the primary, like elementary to the secondary, like 8th standard or 9th standard or something at that time. Okay. I mean, this guy was noted by the teacher, class teacher. It was a math class. And this guy was talking to the classmate, the peer sitting next to him. Okay. So the class teacher gave a punishment to Gauss to do this 1 plus 2 plus 3 plus add up to 100.
Yes.
It's not a normal job, right?
Yeah.
Because this one, n into n plus 1 by 2 was proven by him. But at
Yes.
that time, nobody knows that.
Yeah.
Okay. So immediately he gave an answer like answer is 110, 1010. Okay.
Okay.
And teacher was really surprised. How come he can do very quickly? Okay. You know what he did? He just wrote this whole thing as a S is equal to this.
Okay.
Okay. And also he wrote the same thing in the reverse order. Like 100 plus 99 plus 98 plus dot 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 all the way to reverse order up to 1. And he just added these two. So 2s is going to be 101 plus 101 plus 101 plus dot 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 dot. Last thing will also be 101.
Yeah.
And how many of them are here? There are hundreds.
100.
100 of them, right?
100 into
That
100.
means, yeah, he just wrote this as 2s is going to be 100 times 110. 101.
So
Okay.
S will
S
be,
must be 50 times.
yeah.
Yeah, 101. Then he just did this. At that time, multiplication additions were all available. So 0505. Yeah, this is the answer he gave.
5050.
Yeah, so the answer is actually 5050. So rather than adding all this stuff, so he was the very first person in the world, in our planet, a human, thought about when there are some sequence. And when you have a pattern of numbers having some kind of connection, then they can be converted into, because repeated addition of the same quantity is multiplication, right?
Yes, sir.
Similar to that, he did something like that, and a lot of his work related to the data, numbers, and everything Gauss. So that's why I'm saying this Gauss is a different guy compared to the one in the magnetism. Okay.
Okay.
Okay. So now come to the proper proof. Now let's think about how to do that in the summation form. Okay.
Okay.
Okay, just to have that is a very good idea. It doesn't matter, but immediately when the problem is changed to, if you want to add square of the numbers, like 1 square plus 2 square plus 3 square,
Okay.
then that idea won't work. Do you get that?
Yes, sir.
So that is also been in a formula maybe given to you, but let's go to a very basic stuff here. We are questioning what is this. We want to prove this. When I is running from 1 to n of I equal to what? This is the question we are asking. Okay.
Yes.
Simply, what we could do when we are questioning about I power, because this is the I power 1. Do you get that?
Yes, sir.
When you are looking for a power, whatever the power you are working on, start the problem to prove this with the square of that.
Okay.
Okay, so let's go for the square of this. Do you see what I'm saying?
Yes, sir.
Okay, so now this is going to be, so this is, what is this I squared is going to do for us? Okay, this can be written as, let's split this. Okay, this can be written as summation I equals 1 to n minus 1
Okay.
b squared plus the last term is a n, right?
Yes, sir. Yes, sir.
Yeah, this is correct, but no, this is not the. Yeah. Don't go for this. This can be. Okay, think it this way. Let's change the. This can be written as summation. I am I am adding a, so I start from I equal to 0 . Yeah, 0 to n. When you start from 0, you can still go to n. And this can be written as I plus 1 whole square. Okay, rather, this will be a bit confusing for you. Let me put it what I'm doing now. This, we know that this is actually 1 plus 2 plus 3 plus up to n, right? Right.
Yes, uncle.
Yeah. So let's, if this is running from, then we are saying that this can be written with I running from 1 to all the way to n, isn't it?
Yes, uncle.
That is what the summation will look like.
Yeah.
But what we could do is subtract a, reduce, start from 0, 0 plus 1 plus 2 plus 3. Then we would be adding up to n minus 1, isn't it? Yeah, rather than, okay, I would add and subtract here. And give me a second, okay? 1 second.
Yes, uncle.
Okay. Are you here?
Yes, uncle.
Yeah, okay. So I should have started, what I said was right, but I should have started the square. 1 second, let me erase that. We should start from the add one extra to that, okay? So we should start from asking the question from our I plus 1 whole square. You see that we need a quantity which we can express. We can expand this. Do you get that? Because when you write it as only I, we don't know nothing to expand over here. Do you see that?
Yes, uncle.
So what I'm saying, we need to prove this, but this is
Okay.
something what we are starting with.
Okay.
Why we are starting like this can be written as, this is going to be our, okay, what you know the I plus 1 whole square is, right? So this is multiplication of I plus 1 with itself. This will become I squared plus 2I plus 1, right? Is that okay?
Yes, uncle.
Okay, so now write that. So this will be summation of I running from 1 to n. So this will be written as I squared plus twice I plus 1. Okay.
Yes,
So
sir.
this can be split into 3 summations. One is summation I equal to 1 to n I squared plus summation I equals 1 to n twice I plus summation. You're okay with this?
Yes, sir.
I equal to 1 to n 1. Okay. So this can be written as summation I equals 1 to n. I squared will stay as h plus this. The 2 can be 2 is nothing to do with our running variable I, that can be taken outside. So this will be 2 summation I equals 1 to n I. So this is the part we are interested. Do you get that? This is the one we
Yes,
are
sir.
questioning. So we have to get through that. That is why starting with I plus 1 whole square will get you there. Now tell me, if you add 1 n times, what you get?
N, right?
N, yeah, lowercase n. You're okay with this?
Yes, sir.
Okay, so we got this side is actually computed up to this point. So now look at this side. What is this side actually meaning? So I would go for, take that side. Okay, so this side is summation I running from 1 to n I plus 1 whole squared. What I'm going to write this is actually equal to summation n, I running from 1 to n n squared plus n plus separately n plus 1 whole squared minus 1. What I'm doing here is, we know that, okay, let me get a bit of a room here. Okay, if you're talking about 1 squared plus 2 squared, so what, this is what we are writing it, right? Summation I is running from 1 to n, I plus 1 whole square is what? 1 squared, because the starting value is 1, right?
Yes.
Squared,
Plus 1
3,
plus.
yeah, dot, plus we will have I squared plus last one will be I plus 1 whole square. You get that? Because it has to go up to I plus 1 whole square, right?
Yeah.
Oh,
Yes,
sorry.
sir.
Okay, I should have written n. These are n. Okay, n squared plus n plus 1, not I. Because when you substitute the I running variable value, the very last one will be, because it is running up to n. So it will go to n squared plus n plus 1 whole squared. You are not clear with this. So let's say I equal to 1 to 5, for example. Is
Okay.
that okay?
Yes, uncle.
Okay, how to write this? This is 1 squared plus 2 squared plus 3 squared plus 4 squared
Plus 5.
5 squared plus
Uh, plus and
6
plus
squared.
5, 6 square. Okay, n
6
plus 1
squared.
more. Okay.
Okay, starting one is wrong. This cannot happen. This cannot be there. Sorry about that. Because you
Okay.
start with only 1, right? 1 will become 1 plus 1
Okay.
is a 2 square.
Yes, uncle.
Okay, so this is what I have written. Summation I running from 1 to n I plus 1 whole square will look like that. There will be 2 squared plus 3 squared. That will be the series, right? Plus
Yes.
all the way to n squared plus an extra term. N plus 1 whole squared will be there.
Yes, uncle.
So I'm going to take this and I'm going to add. So in this, so let's write it here, okay, for easy understanding. So I'm going to take this 2 squared plus 3 squared plus up to n squared plus n plus 1 whole squared is our summation I equal to 1 to n I plus 1 whole square, right?
Yes.
Okay, I plus 1 whole square. Now what I'm going to do, purposefully I'm going to add a 1 squared here. Okay, and all this thing I'm going to write as such. That will be 2 squared plus 3 squared plus dot plus n squared. I mean, of course, we will have this n plus 1 whole squared, and whatever the 1 square I added, I'm going to subtract that. Is that okay?
Yes, sir.
Why I have done that? Now this whole thing can be written as summation n equal to I mean I equal to 1 to n I squared, right?
Yes, sir.
I squared plus n plus 1 whole squared minus 1.
Yes, sir.
Okay, so this is the one I have written over here. Same thing.
Yes, sir.
Okay, so what we have done, the I plus 1 whole square running from 1 to n split into 3 terms conveniently by looking at the actual expansion of what is our I plus 1 whole square. Looking at very carefully, it is missing with 1 square in the front and the extra 1 term of n plus 1 whole square at the very end, because when we carefully add that 1 square and subtract 1 square, from 1 square up to addition of n plus n square, that can be written as a term which we are going to handle it carefully. So now we know that this side can be written as coming from here, that will be summation of n equal to 1 to n I squared, right?
Yes, sir.
Here there has to be a simple mistake is there. Let me erase that. This is a I. This is a I. Do you get that? Running variable is a I.
Yes, sir.
Yeah, I put a n. Okay. So this side, I'm writing it from here. Okay. So this is I square plus 2i's summation I running from 1 to n I plus n, which is actually equal to summation I running from 1 to n I squared plus n plus 1 whole squared minus 1.
Yes.
Okay. So in this case, this I squared, this guy and this guy can get cancelled.
Okay. Yes, sir.
Okay. So once we have done that, this is the one point of interest. So this will yield us summation I running from 1 to n I is actually equal to this n, this side is n plus 1 whole squared minus 1 minus n whole thing divided by 2. Because the 2 is available.
Yes, sir.
You get that?
Yes. Yeah.
Okay, so now just expand this. So this will be n squared plus n
Plus n
minus 1, 2n. Sorry.
So it will be minus 2.
Yeah, n squared plus 2n plus 1.
Okay, yeah.
Minus 1.
Minus 1 minus n.
Divided by 2.
Yes.
Okay, the minus this
One
one
minus.
will cancel, and one of the n will be, so this will look like,
N square minus n plus 2n.
yeah. Now we have proved it, right?
Yes.
So this will be n squared plus n whole thing divided by 2. So this can be written as n into n plus 1 divided by 2. Okay, let us do it again to get a good idea why we did it and how that will help us to go for. So simply we are saying that our point of interest is summation I running from 1 to n I. Okay, so this is the point of interest. What we are doing, take the summation I running from 1 to n, start with I plus 1 whole square.
Okay.
Okay, so this can be written as summation I is running from 1 to n. This can be expanded as I squared plus 2i plus 1. Okay, so now the summation can be distributed. I equal to 1 to n I squared plus 2 can be taken as a common outside, which is independent of I running variable I plus our n itself. We get that. That one will add up n times, that will be n.
Yes, sir.
Okay, so this is one way, one side we deal with that. Other side is start with our summation I equal to 1 to n I plus 1 whole square is nothing but 2 squared plus 3 squared plus 4 squared plus dot 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 plus n squared plus n plus 1 whole square. Right?
Yes, sir.
Now we are going to, in this, add 1 squared plus 2 squared plus 3 squared plus 4 squared plus dot 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 plus n squared plus n plus 1 whole squared minus 1 squared. So this, whatever the thing we added, we subtracted. Okay.
Yes,
But
sir.
this will actually help us to combine all this quantity into a I running from 1 to n I squared plus our this n plus 1 whole squared can be expanded here, which is outside the summation. That will be n squared plus 2n plus 1 minus 1. Is that okay? Yes. So the plus 1 and the minus 1 can cancel. So this is going to tell us, this implies the summation I running from 1 to n is of I plus 1 whole square is nothing but summation I running from 1 to n I squared plus n into, okay, no need to put the n into, we can just say that n square plus 2n. You're okay with that? I'm just writing the one we got from this side. Is that okay?
Yes, sir.
Your S is not coming very bold.
Yes, uncle. Yes, uncle.
You're okay, right? So this side, from this we got from whole this thing, from this workout, we got something like summation I equals 1 to n I plus 1 whole squared is actually equal to summation I equal to 1 to n I squared plus 2i summation I equal to 1 to n I plus n. Okay, so this workout has led to this. You catch that? So there is one way of writing the I plus 1 whole square. This is another way. Now we are going to equate these two.
Yes.
Just the left hand side, right hand
Left
side.
hand side is equal. So
yeah. So that will lead to
the first term of both will get
I equal to 1 to n I squared plus 2i summation I equal to 1 to n I plus n must be equal to summation of I equal to 1 to n I squared plus n squared plus 2n.
Yes.
Okay, so these two terms can be cancelled.
Yes.
And one of the n can be also cancelled. Do you get that?
Yes, sir.
Okay, so that leads to our twice summation I equals 1 to n. I is actually equal to, this side n can be factorized, so this will be n plus 1. So this actually leads to our final one. What we want to prove is I equal to 1 to n into n plus 1 over 2. Is that okay?
Yes, sir.
So now we could use the same logic and idea for something like, let's say we are interested in finding summation I running from 1 to n. This time we want I square itself. Let's say we are interested in this. Then the same logic. So what we need to start is summation I running from 1 to n I plus 1 whole cubed. You see that?
Yes, sir.
How this is going to help us? Now let's expand the I equal to 1 to n, and the cube can be expanded as a I cubed plus
Plus 1
3i squared plus
plus,
I plus 1.
yes. Nice.
Okay.
Uncle, it's AB square plus.
Yeah, this is a 1, right?
Oh,
I
okay,
plus
okay.
1, right? The B is a
No.
1. A is a I.
Okay, yeah, yes, uncle. Shouldn't it be 9?
No, expansion is a plus b whole cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed, right?
3A square. Okay, okay, fine, fine. Yes, uncle. Okay.
Okay. A plus b whole cubed is a cubed plus 3a squared b plus 3ab squared
Okay, yeah,
plus b
fine.
cubed.
Yes, uncle. Yeah, got it.
Now we are saying I plus 1 whole cubed is going to be I cubed plus 3i squared plus 3i plus 1.
Okay, yes, 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 fine.
Okay, so this will be, I don't write the I equal to 1 to n running is keep repeating again. It's okay. I cubed plus 3 summation of I squared plus 3 summation of I plus
Plus
n. N.
plus, yeah, yeah.
N will add up to itself. Do you get that?
Yes, uncle.
Okay, and also we have just solved this one. Do you get that? So this will be written as summation I cubed plus 3 summation I squared, which we are interested in, plus 3 times 3 by 2 n into
N minus N into
n plus 1.
N plus 1.
Plus,
Right?
is that okay?
Yes, uncle.
Okay. So on the other side, what we need to do the same way. So when we start this, expand it and you will get the idea what to be done. So this will be I plus 1 whole cubed. This can be written as starting value will be 2 cubed plus 3 cubed plus ... It will go to n cubed plus n plus 1
N
whole
plus 1. Yeah,
right.
okay. Yes,
Now add the 1 cubed plus 2 cubed plus 3 cubed plus ... plus n cubed plus n plus 1 whole cubed minus 1 cubed.
Yes, uncle. Yeah.
Okay.
One second.
1 second. Yeah.
Plus 1, 2.
Okay, so far.
Yes, Uncle.
Okay, so now we could completely write up to, okay, completely write up to here as summation I cubed, right?
Yes, Uncle.
I cubed plus our n plus 1 that can be expanded. That can be n cubed
Yes.
plus 3n squared plus 3n plus 1 cubed. That will be 1 minus 1. So these two will get cancelled.
Yes. Yeah.
Okay, now we can equate this with this guy. So that will become summation okay. So you got the idea, right?
Yes,
What
Uncle.
we are doing. Okay. So I stop here.
Okay.
You solve this and you will get the one which in the book they may be given as a formula for you, but you will get
Okay.
the exact answer. Okay.
Yes, Uncle.
Okay. We meet next week
Yes.
then.
Okay.
Okay. Take care. Bye.
Bye.